My name is Josh Bailey, so I'm going to shortly attempt to entertain you with this sensibly sized Tesla Coil and a Commodore 64 SID chip-based synthesizer called an electron SID station. So since we're using a Tesla Coil today, there's a few safety notices that you must observe, and Erica helped us with the first one. The first is, please do not touch the Tesla Coil. That would be bad. You will affect the sound that comes out, and so I won't like that. It will also affect your operation as well, possibly permanently, so don't do that. So no Area 51, see them Tesla coils, anything like that. Okay, the second thing is, so it's in a cage, it's a partial Faraday cage, so that will block a lot of its interference, but it is theoretically possible it may generate some interference to very sensitive, RF-sensitive devices. So I'm very sorry, but if you're in possession of a really sensitive device, like a pacemaker or something like that, you'll have to leave the auditorium now and view it from outside. Never had a problem before, but I think that's really the safest thing to do. The next thing is some parts of the performance may be a little loud. So if you don't like loud things here at the front, we have one of our safety volunteers has a box of earplugs, so she's raising them up now. Thank you. So you're welcome to use those if you like. So that'll be in about a minute or so. And finally, the last safety notice is, I'm a software engineer. I'm not a musician. I'm just saying. Thank you. And there is a risk that like Tesla's ghosts will appear and go like, oh my God, what are you doing with my invention? Okay, so now that we're out of the way here, I'm going to insert my Allen key. So we are now armed. Very good. And in the manner customary of electronic music, I should now press play. If I can find play. Good enough. just realized there I missed my sign for days since last resonance cascade failure, kind of 0 or something like that. Thank you very much. So I'll demonstrate some other effects here. So back there, the coil is now disarmed, by the way. Now I'm going to explain to you a little bit what we just heard. There was a, as I said, I'm a software engineer, not a musician. There was a little track called Unscheduled Sunrise that I've written here for these two devices. And I'd like to describe to you how I got here, what's coming next, and how the system works. So my name is Josh Bailey. I have a long-running project, sometimes separate to work, on exploring control of various things and physical systems and things for various effects. So in this case, power. And this whole journey started about 10 years ago at the Nevada Lightning Lab, where I did some work for a man called Greg Lay, who runs it. The Nevada Lightning Lab, paradoxically, is not in Nevada, it's in San Francisco. The goal of the lab is to investigate different kinds of electrical phenomena, including anomalously long lightning strikes. So here we're using two of Greg's smaller coils. They're both 8 feet high. They're operating together to form an arc that's about 20 feet long. There's another coil back there that's bigger, as you can tell from the gantry crane. So I had a very, very understanding boss also at that time. You could say to him, so I'm just going over to Mythbusters to blow some things up. He's like, okay, just don't get in the National Enquirer. So we observed this constraint very strictly. However, there was an incident where a cannon did overshoot the range, and it did hit my coworker's house. But I will observe this was not reported in the National Enquirer, so and my coworker was pretty cool about it. So anyway, things are starting to get a little bit out of control here. This is recently, Greg has, at the anniversary of Tesla's birthday, on his way to 150-foot arcs. He can now produce 42 to 50 feet. That's a 3 million volt spark, drawing about 210 kilowatts. And it's a lot of fun to be around, I'll tell you that. So 30-second Tesla coil explanation, I guess, like if you don't remember your Tesla coils from school. So over on the left-hand side to the right, basically a Tesla coil is a kind of electrical transformer. You can exchange volts and current from more volts and less current. So over on the left, this is like the simplest design. You have your low voltage, like 220 or 110. Comes to a little transformer to step it up some, maybe to a couple thousand volts. And then you have a circuit, C1 and L1 together. They resonate at a frequency, like a tuning fork. And then there's a switch, or a spike gap there. There on the right-hand side is another circuit. You see it's not electrically connected, it's just adjacent, formed of L2 and C2. And they resonate together with the first coil. So if you open and close the spike gap, adding more and more power to that first circuit, the primary, you get more and more energy transferred to the secondary system. So for, say, 11,000 volts in, you might expect to get over 1 million volts out on the other side. So unlike a Van de Graaff generator where you get that energy delivered in one kind of blap, a coil can deliver this power continuously. So centering on the spark gap in the center, that's where I'm going to concentrate most of my time explaining, because that's where all the complex stuff happens. All right, so this is now about 9 years ago. This is part of my journey of trying to understand and control large amounts of power. What you see here is a perfectly reasonable household appliance. In the back is a power pole transformer. So we feed 3-phase power into that. That produces about 11,000 volts at quite some amps. Well, some amps. That's doubled to 22,000 volts DC, which charge these capacitors, which Brookhaven National Labs don't need anymore apparently. That's connected to a pole, and then we get our common and/or garden 14-foot Tesla coil and attack the capacitor bank with the coil. hopefully generating some kind of bass note. So here are some stills from a video. As you see, I am hiding in a shipping container, seems appropriate, with the capacitor bank control panel in front of me. The coil has started and it's about to contact the positive electrode of the capacitor bank, so that's nice. The connection has been established, and plasma enhancement has occurred. The energy from the bank leaves through the established plasma channel, goes into the coil, comes out again. This results in something known in academia and research as a satisfying bass note. It also is good for scaring away pigeons, removing paint from the ceiling. And other strange things can also happen. So, so the plasma channel is still established there after a little while. But you see, strange things will happen when coils are around. Shortly after this, the camera went somewhat catatonic and could not be recovered. So something actually to keep in mind, it's fun to play with large amounts of power, and it can be done relatively safely, but lots of our modern electronics are not really designed to resist EMP or anything like that. So we, as part of this whole journey, had to actually try and find ways to protect all these delicate instruments from what's happening in this cage. So coming now to New Zealand, this very peaceful scene. This was, until recently, one of the world's largest Tesla coils. It is on Alan Gibbs's art farm, about an hour's drive north of Auckland. It's built into a hillside outside Alan's house. And it does have a cage up there, so you can get up in there. And I'll show you that in a second. This coil is using a spark gap, and it has its own private power feed from Transpower. It can draw 135 kilowatts, and yes, we did blow the fuses at some point. A nice man in a Hilux has to come out with them, and there's paperwork. But until the paperwork arrives, it's a lot of fun, I have to say that. One of the most fun things about this coil, and the other 14-foot coil you've seen, and I have done this, there is video, you can actually be up in this cage, and you can take something like, so you're sitting up at about 1 million volts or so, sitting on the high voltage terminal, and then you can put like a broom handle through the bars of the cage. This causes the electric field to enhance off of the end of the broom, so you can throw lightning bolts at people on the ground. This causes people to scream and run away in a very gratifying manner. I highly recommend it. However, you sometimes notice your hands start glowing and other things. But anyway, so stepping back here, this is the control panel for the coil. So it has the right numbers of stop buttons and go buttons. But there's a kind of primitive control over the sound that you can get from the system. So on the right-hand side, you can vary the speed of the gap motor, which I'll show in a second. So that lets you imprecisely tune kind of the sound the coil makes. You can either have like a low buzz or a high buzz. It's quite challenging to switch 135 kilowatts like this. So here's how we do it down the switch volt at the bottom. I actually did have a shot of being chased by a llama with an oscilloscope while running through a field. This is like, what is happening here? So you can just see, for scale, in the background there, inside the switch volt, is the spark gap, rotary spark gap of motor. So a little bit closer here. So this is a 135 kilowatt switch. This rotor rotates, opening and closing as it does so, and power goes in and out, and hilarity ensues. And there, so it's quite a high maintenance system, just like the distributor in an older car. You have to do quite a lot to keep it running. Okay, so I guess that's pretty good for picking kind of one note and tuning it up and down. But there's another part of the system. I'm sorry about this shot. It's the only one I got here. It's poor contrast. But what you're seeing is that resonance effect that I explained earlier. So at the top on the yellow trace, There's like a three kind of bump pulse. That's one shot of the spark gap motor closing a switch. So a little bit of power has gone in, well, quite a lot of power. And at the bottom you'll see like this really long oscillation on the secondary. That's the secondary ringing with the energy that's being input into it. Oh yeah. So I've learned many things from Greg, and one of the amazing things is his design aesthetic. I think this is entirely appropriate. Like, yeah, Hello Kitty's eyes will glow in a menacing manner when the system is ready. We've added some other elements, like on the system I have up here has a key switch and a fire button, so it's hard to take on a plane these days. But he doesn't really bother with the key switch, so I guess that's good. All right, so big Tesla coils are fun, and you can exert some level of control. But what if you have a slightly greater level of control? So instead of a spark gap, you can switch the power on and off as you like. So in this complex and precisely drawn diagram here, this is the first coil that I built in New Zealand, having moved here a little while ago. So in the center, that weird transistory kind of looking thing, that's a kind of transistor called an IGBT, insulated gate bipolar transistor. They can really switch a lot of power. So the smaller versions of these you can find in like electric cars or electric buses. If you're standing near one, you hear this kind of high-pitched whine as it's taking off from a standing start. You're hearing some IGBT noise. But these transistors are bigger, and the one I'm about to show you, it actually has other transistors, and it has a whole other system just to turn the other big transistor on and off. So yeah, so what could I do if I have such a transistor? Well, I have to get the transistor first. So here's the first one that I got with my projector at home for scale. So it actually has, just like a regular transistor, it has a collector and an emitter and a base, so you can rig it up. The difference in this transistor is it has export restricted technology. So people really want to know why you have it, and that puts me on yet more lists than I'm on already. But people are nice. So the difference, this transistor, among other IGBTs, it can switch 10,000 amps and do that in 1 microsecond at 1800 volts. And it can do it again and again and again and again. So it's used for uses which I cannot discuss. But another fun use for this system, a friend was on the review committee for the LHC beam dump system. So the LHC beam, while it's running, has about the same kinetic energy as a battleship going 20 knots. So you cannot just turn the accelerator off when you're done, or like an emergency. So his design is a machine that uses a whole gallery of these, and they power these giant magnets that pull the beam out of the ring and throw it down a tunnel where it hits like a 100-meter concrete block and drills a hole in it with horrible X-rays and everything else. So yeah, they're useful devices. They also stop your table from blowing away in the wind. So at this point, things got a little bit out of control, and my friend Patrick Hurd decided that obviously this needs to be water-cooled. So there's a nice article here on Hackaday about that. Should have cleared up my workshop, maybe, before the photo was on there. But what you're seeing, the IGBT is hiding behind those support posts in the center. There's a 2,000 volt capacitor bank over on the left, though we don't run it over 1,000 volts. And there's a quality warehouse product water reservoir there, and some fans and other bits and pieces. It's made mostly out of things from Mitre 10, things from that you shouldn't buy, and old welding machine. Oh, yes, an old welding machine power supply in that. Okay, so having got this working and running at the end of my driveway and terrifying the neighborhood, I'm like, well, what should I do with this? So I need some way to control this with a keyboard. As I've mentioned, I'm a software engineer, so no business making any hardware. So here's the first version of the controller. It's called Pipe Organ. MIDI input over on the right, and it has a nice key switch, so that's nice. This system you can do like 4 notes at once, you can do some pitch bending. There was a first version that's actually still sitting on my desk at home. It still works as far as I know. We thought, well, this is no fun just to have at home. We should try and show it to people. So we went to the nice people at Victoria University School of Design. We went to the engineering department first and they said no. So we went to the School of Design and they said yes. Man, design people are so nice. So down at, so here's me, there's Patrick there just in the background, and down the bottom is an artist, Jade Hooker, who composed an original piece for it. And gosh, that was a lot of fun. We actually also had another colleague. She designed a fluorescent light to kind of mobile thing that went over there, and it would light up and respond to the coil as it was playing. That was pretty cool. I think that broke eventually, but it was cool. Okay, so once we did that, we're like, well, we need to make this like easier to use for musicians. So what you saw just before, we've written a system that's easy to use with something like Ableton or Pro Tools, so your artist doesn't need to know anything about high voltage or anything like that. They can just kind of arrive and push buttons and have things happen. So of course this resulted in a bit of a paper, some research, some conversations. You probably need more notes. You need to be able to do oscillator detuning. You need low frequency oscillators, all that stuff. So we wrote a paper together, and then we built the synthesizer itself. So that's what's on stage here. That's what I was using. It's very conceptually pretty simple. The MIDI goes in, and commands to the coil come out over a fiber optic cable. All right, so since we had this, what came next? Well, if you have, if one coil is not enough and 2 is too low, you have to have 3 at the same time. So Jason Long produced a track using 3 coils, a robot bass player, and a robot drummer. And despite having to do a few takes, pretty much everything worked, except we did have an issue with the drummer. We didn't know quite as much about interference mitigation here as we do now. So the drummer control system got jammed by the coil. Several actuators triggered without us noticing, and then caught on fire. So we addressed this part of this performance issue by throwing pieces of the drummer out of the window, so they would not trigger the fire suppression system, which would be embarrassing. So there is no video of that, by the way. It's a shame. The other thing, actually, if you also look for the videos of the bass player, the robot bass player, it's actually quite mesmerizing to watch. There's these wonderful little actuators like plucking the strings, and they can do some pretty awesome slides. And it does actually have to be strapped down, otherwise the bass player will wander about the room. So that was okay. But I am an industry standard old white guy from the 70s, and so I had a Commodore 64 growing up. And so I was like, well, what if we had some combination between kind of Commodore era technology and Tesla coils? What could go wrong here? So what you're looking at is a program that I came across a while ago. It's called DefBond. You're looking at 50% of the UI, and I'll show the other half of the UI. So it's otherwise known as hex numbers. What you can do is just poke register values into the sound chip arbitrarily. So these are little sound programs going from top to bottom. And if you really know what you're doing and understand all the quirks of the chip, you can produce some really amazing things. So this is one half of the UI, and here's the other half of the UI, where you can have up to 3 channels, or you can have another 3 if you have another sound chip, and you schedule notes, and then those blue numbers are sound programs that are triggered in that other screen. So I'm sure now you've seen the entire system. You can sit there and instantly start producing lots of music right away. I do have a tutorial video on that, by the way, so hopefully maybe more than one person will here will play music with me. So yeah, I don't really know how to use this program at all, but I made a friend, a guy called Anders Karlsson, or otherwise known as Go280 in Sweden, and he's produced some pretty amazing stuff. If you go to go280.com and listen to some of his work, it's all produced sometimes by him literally live coding the stuff on stage. It's incredible. So we thought, well, can we do a concert together? And he's a very nice man, so he said yes. So he agreed to come to Wellington, and we had a colleague of his produce this Petsky poster, and had another friend who added her vocals. So there is actually an album called Song Ionic, which you can find with all of us in it in one way or another. Anders is the guy with all the talent. Anders in the piano. And yeah, we did actually try to do a public performance in Wellington, but I could not find the right form. It's very sad. So we did it at my house, and as far as we know, no one died, so that's good. So here, this is another Tesla coil in its natural environment. I have a few Tesla coils. I don't have a problem with that or anything. But this one's a small one. You can't see it. It's actually in that complete Faraday cage up top. So this is your typical Tesla studio that I'm sure you've seen before. Over on the left is where you have your Commodore 64, of course, and your display to work on that. Anders is making Ableton work again after it died. And over on the top right, you can see there's my coil sitting in a box, and it has kind of one of those kind of bus driver cameras in there, so we can see what the coil is doing. And one of the advantages of doing this is because it's a complete cage, we can completely control the, we can eliminate reverb or anything like that. You can actually run it for hours. Hours and hours. There's an air quality system in there so that everything stays nice and fresh, and you can have a great time. Okay. So what's next? Oh yeah. What can I say here? If I were to review this movie, it has some intriguing ideas, I'm going to say. It's intriguing. There are some differences, maybe, to the book. But another thing that's interesting, if you go to this YouTube link there at the top, there's a video there about the audio production process used in the film. And there's something to do with Tesla coils in there. So you may find that interesting. And almost finally here, I'll do a little kind of demo of some of the effects here in a minute or two. So what you're seeing here, this inspired the next stage of the product. This is a product. Using a Commodore 64 to actually replace Ableton, because Ableton makes me sad. I don't want to use this stupid Mac. So what if we could actually run the entire show, not just some of the audio from a Commodore 64? Unfortunately, a lot of the MIDI interfaces from the 80s are just too slow or CPU expensive. So I have designed a MIDI coprocessor for the Commodore 64 here. The software is in development, but we've been able to get like 100 kilobytes a second kind of out of it, so we think that's got enough bandwidth for MIDI easily. And I've got a friend, the DefMon author, who's adapting DefMon to have greater MIDI capabilities. So hopefully, the next time I see you, get rid of this horrible Macintosh, and we can run the entire system completely from a Commodore 64. But yeah, if you're interested in participating in this, please let me know. Okay, maybe here I'll just show you a couple of effects here, some of the things the coil can do. So I'm just going to go ahead and arm the system again. Go back into Ableton. Oh, how I love Ableton. Okay, the coil is armed now. So, basic kind of effect, obviously. A fun thing you can do to distinguish this from other coils is you can do live, like, oscillator detuning. if you want to engage in a genre that I call a coil step. This is really fun on the really big coil, let me tell you that. So you can also do, this called like high resolution pitch bends. So far as we know, this controller is the only controller currently capable of doing this. You can get other controllers which can produce these other simple kind of tones, but due to a lot of help from musicians and other nice people, we've been able to understand more what an actual artist would need from it to integrate it with a performance. There's also ADSR in here, so you heard a little bit example of that, so you can, I'll just turn up the envelope here. You can actually have it like fade away rather than just kind of just batter away at you. Oh yeah, I'll try one more thing here before I'll turn it off. So let's turn, okay, show do other wacky. It's not quite what I wanted, but yeah, for some other work, the nice sound people were like, make a terrifyingly bad sound. So I'm like, okay, I'm really good at that. Okay, the coil is now safe, and I'll just like to say thank you. So I'm really deeply appreciative to Erica and her crew, because having this kind of perfectly safe death ray thing here is very stressful, and a lot of people did a lot of work to enable us to bring it in here, and really deeply appreciate that. I know, like Sefton in particular is a very patient man who's really helped us, and also the venues Wellington Spyglass and NW Group. And also my volunteers who prevented this kind of Area 51 see them tears the coils rush, so that's also good too. All right, thank you very much. If you've got any questions about the system or anything, I'd love to talk to you about that. And I guess I'll get out of the way now. Thank you.